Hello, students, and welcome to our May 5th lesson. We are all virtual today. Our assignment today will be to complete the Do Now prompt about using mindfulness. Watch this video, complete 3 assigned pages today, and submit photos of your work for teams. For homework, we started homework 2, but for tonight, I want you to complete it. You did 4 problems last night, and you'll complete that tonight. Our Do Now today is about mindfulness. That's our theme. Mindfulness is the ability to know what's in your head without getting carried away by it. I love that definition. So how can you use mindfulness to help you learn something new? How can mindfulness help you learn something new? And I'd love you to answer that right there. So let's get started with our lesson. I believe we are on number 5 at this point. So we're using the strategy of first we find the axis of symmetry. After we find the axis of symmetry, we determine the vertex. Then we make a table of values, starting with our vertex in the center of the table. We substitute to our x values to determine the coordinating y values, and then we plot the quadratic. So we're on number 5, y equals x squared minus 6x plus 11. So we'll start with the axis of symmetry, whose equation is b divided by 2 times the quantity of a. So let's determine in the number 5, our a is a positive 1, and our b is a negative 6. You want to include that sign with the b. So our axis of symmetry is negative 6, be careful with those negatives, times 2, divided by 2 times 1, which will equal 6 over 2, which equals 3. So the axis of symmetry is x equals 3. Our vertex, we will substitute 3, so we have 3 squared minus 6 times 3 plus 11, and that's y equals. And when we evaluate that at 3, y equals 2. So our vertex is 3, 2. So we'll put that right in the center of our table. The x value is 3, the y value is 2. So we'll evaluate 2 points less than and 2 points greater than x equals 3. And when we substitute 1 into this quadratic, we have a y value of 6. When we substitute 2, we have a y value of 3. When we substitute 4, we have a y value of 3. And when we substitute 5, we have a y value of 6. So let's plot those points. That's 1, 6, 2, 3. And we know this is going to be an upward facing parabola because the a value, that positive 1, is positive. So 3, 2, 4, 3, and 5, 6. And we'll connect those with a smooth curve. And we see that our domain is all real numbers, and our range y is greater than or equal to 2. So let's move on to number 6. So y equals negative x squared minus 2. Our parabola will open downward. And let's evaluate our a and b. So a is negative 1, and our b value equals 0. There is no b value. There's no linear x term. So if the b value is 0, then the axis of symmetry has to equal 0. And we can do that out. That would be negative 0. There's really no such thing as negative 0 times 2 divided by 2 times negative 1, which equals 0. So if we evaluate this expression, this quadratic at 0, substituting 0 for x, y would equal negative 2. So our vertex is 0, negative 2, which we can put right here in the table. And then let's evaluate points lesser than, and greater than for our x. And as we evaluate x at -2, our y equals -6. When we evaluate x at -1, our y equals -3. When we evaluate x at 1, y equals -3. When we evaluate x at 2, y equals -6. So let's plot those numbers. There's our -2, -6, -1, 3. And this has a negative a value, so this will be a downward facing parabola. 0, -2, 1, -3, and 2, -6. And there is our downward facing parabola, which we connect with a smooth curve. We can see that the domain is all real numbers, but y is all the values such that y is less than and equal to -2. Okay, number 7. We have y equals 2x squared plus 8x. There is no c value in this particular quadratic. So let's just get started with what we have. Our a value is 2 and our b value is 8. So we'll find the axis of symmetry. So -b, so that in this case, that would be -8 divided by 2 times the quantity of a, which is 2, which would be -8 divided by 4, which equals -2. So our axis of symmetry is x equals -2. So let's evaluate for the vertex. So we will evaluate y equals, and that would be x is -2. We would evaluate it 2, -2 squared plus 8, -2, which would equal -8. So our vertex is -2, -8. And let's put that immediately in the center of our table of values, and we can evaluate 2 values that are smaller and 2 values that are greater. So when we evaluate this quadratic at -4, y equals 0. When we evaluate this quadratic at x equals -3, y equals -6. When we evaluate this quadratic at x equals -1, y will equal -6. And when we evaluate this quadratic at x equals 0, y would equal 0. And you can see the parabolic pattern there. In the table of values, particularly in the y values. So let's go ahead and plot this. This will be -4, 0, -3, -6. So 1, 2, 3, 3, 4, 5, 6. -2, 8, 3, 4, 5, 6, 7, 8. And that's our vertex. -1, -6, and 0, 0. So look at this. A long, thin parabola. And when we look at that, we see that the domain is all real numbers, and the range, well, let's look at this point right here. This is our point y equals 1, 2, 3, 4, 5, 6, 7, 8. So that's y equals -8. So our range, is all the values such that y is greater than or equal to -8. So let's move on to number 8. We have -x squared plus 4x plus 3. And we see this negative a value, so our a value is -1. That means we will have a downward facing parabola. And our b value is 4, positive 4. So let's find the axis of symmetry first. So that would be -4 divided by 2 times -1, which equals Negative divided by negative is a positive, so that's going to equal 2. So the axis of symmetry is x equals 2. And let's substitute 2 in that quadratic. So we have negative, and our x equals 2 squared plus 4 times 2 plus 3. And when we evaluate that for our axis of symmetry, which is 2, it equals 7. So our vertex is 2, 7, which we put right there in the center of our chart. And we can plot the vertex right now if we want. 2, 7. That's our vertex right there. Remember, this is a downward facing parabola. So let's evaluate also for 2 smaller and 2 larger. And now when x equals 0, y equals 3 in this particular quadratic. When x equals 1, y equals 6. When x equals 3, y also equals 6. And when x equals 4, y equals 3. And we can see the parabolic values emerge from our table of values. So let's go ahead and plot those points. We'll plot 0, 3, 2, 7. We have that 1, 6. Let's do our 1, 6, 3, 4, 5, 6. And our 3, 6. And our 4, 3. There's our parabola. So let's connect those lines with a smooth curve. And we see that our domain is, again, all real numbers, and our range is going to be values that are y is less than, right? Less than or equal to, and 1, 2, 3, 4, 5, 6, 7, y is less than or equal to 7. So I hope you can try 9, 10, and 11 yourself, and then come back to the video. And I will be doing all of these, and then we will analyze a graph. So number 9, y equals negative x squared minus 2x. Our a value is negative 1, so this will be a downward facing parabola. Our b value is negative 2. Be careful with a negative b value. So to find the axis of symmetry, it's negative, negative 2 divided by 2 times negative 1, which equals 2 divided by negative 2, which equals negative 1. There we go. So x equals negative 1. Now let's evaluate this quadratic at negative 1. So remember, this is negative, negative 1 squared. And we don't have a c value here. So negative, negative 1 squared minus 2 times negative 1. And when we evaluate that, we find that our function equals 1. So our vertex then is negative 1, 1, which we can put in our chart, and we can also go ahead and plot it. And since this is a downward facing parabola, we know that we can actually know that our range, if we trust our work, is going to be all those values of y such that they are less than or equal to positive 1 going downward. So let's evaluate this quadratic at negative 2, negative 3, 0, and 1. And when we evaluate this quadratic at negative 3, the y value is 3. When we evaluate negative 3, when we evaluate it at negative 2, the value of the function is 0. When we evaluate at 0, again, the value of the function is 0. And when we evaluate at 1, the value of the function is negative 3. So let's go ahead and plot negative 3, 3. Negative 3, negative 3, right there. Negative 2, 0, We have already plotted our -1, 1. Then we have our 0, 0, and our 1, -3. And here's our quadratic. And our domain is all real numbers. And as we suspected, the range is all the values of y such that y is less than or equal to 1. So let's move on to number 10. Y equals -3x squared minus 18x minus 20, which will be a downward facing parabola. Our a value is -3. Our b value is -18. Let's be very careful when we evaluate this. So negative b, so -18 divided by 2 times -3. We're evaluating for our axis of symmetry. So that would be a positive 18 over a -6, which would equal a -3. So our axis of symmetry, x equals -3. To evaluate the vertex, I will find the value of this function at -3. So -3 squared minus 18 times -3 minus 20. And when I evaluate all of that, my function is worth 7. So when x is -3, my y value is 7, and I'll put that right into my table of values immediately. So let's also evaluate at -4, -5, -2, and -1. So when we evaluate this function at -5, the y value, the value of the function is also -5. When we evaluate at -4, the value of the function is a +4. We already evaluated at -3. When we evaluate at -2, the value of the function is 4. And when we evaluate at -1, the value of the function is -5. So let's plot those points. So we have -5, -5. This is going to be a big quadratic. It'll cover a lot of the graph. We have -4, 4. We have our vertex, -3, 7. Then we have -2, 4, and -1, 5. And let's try to get a nice curve going. Oh, I think I can do better than that. Maybe I need to change the color. That's a little bit better. And we see that even though it's a narrow parabola, the domain will still cover eventually from -infinity to +infinity, and will eventually cover all of the x values. So we can say the domain, is all real numbers, but the range is all the values of y such that y is less than or equal to 7. And let's do number 11. So don't be afraid of the fractions. Don't get fractionitis on me here. So our a value is 1/2. I guess if it's easier, you could work with a decimal. I choose not to. And it's a positive a value, so our parabola will open upward. Our b value is -6, so be careful evaluating. So we will have, I think I'm going to work over here, negative b, which is -6, divided by 2 times 1/2. So that would be +6, half of 2 is 1, which equals 6. So our axis of symmetry, x equals 6. Let's find the vertex. So we're going to evaluate y equals 1/2 times 6 squared minus 6 times 6 plus 11. And when I evaluate all of this, the value of the function is -7. So our vertex is 6, -7. Okay, let's plot 2 points smaller and 2 points greater. And when we evaluate this function at 4, the function is worth, the y value is -5. When we evaluate this function at 5, the y value is 6.5. When we evaluate at 7, the y value is 6.5. And when we evaluate at 8, the y value is, that's -6.5. These are all negative. And at 8, the y value is -5. So you can see that parabolic pattern coming out. So we have -5, -6.5, -7, -6.5, back up to -5. So 4, -5 is right here, and this will open up. 5, -6.5, which will be right there. 6, -7, right there. 7, -6.5, right there. 8, -5, right there. So this is our parabola. Opens a little wider than some of the other ones we've done. So again, the domain is all real numbers, and the range is all the values of y such that y is greater than or equal to -7. So the next thing we have today is to analyze a quadratic graph. So we have graph A and we have graph B, and we're going to look at those and we're going to compare them. And so let's take a look at that, and let's start that now. So here we have graph A and graph B. I think I might want to make that a little smaller. So well, let's answer some questions. So okay, so graph A is an upward facing parabola, must have a positive A value. Graph B is a downward facing parabola, which has a negative A value. So the first question, what is the axis of symmetry of graph A? So the axis of symmetry is right here. So the axis of symmetry for graph A is x equals -2. Let me write that a little neatly. And the axis of symmetry for graph B is right here. I should put arrows on those. And the axis of symmetry is x equals 3. We're counting each one of these units as 1. The vertex of graph A is right here. So that would be -2, and our y value is 1, 2, 3, 4, 5, -5. And that would be a minimum because it's an upward facing parabola. The vertex of graph B has an x value of 3 and a y value of 1, 2, 3, 4. And that is a maximum because it is a downward facing parabola. Okay, so the domain and range of graph A, the domain is all real numbers, and the range is all the values of y such that y is greater than or equal to this point here, which is -5. Now the domain and range of graph B, the domain is all real numbers, and the range is all the values of y. Let's take a look at it here. All the values of y such that y is less than or equal to 1, 2, 3, 4. Okay, so identify the equation for graph A. So take a look at those choices. Graph A has a positive A value, so it cannot be C and it cannot be D. So we're looking for an axis of symmetry of x equals -2. So we have an A value. Let's look at A. We have an A value of 1 and a B value of -4. So let's evaluate and see if we end up with x equals -2. So -4 divided by 2 times 1 equals 2, positive 2. And we need a -2 up here. So A is not the correct answer, so I'm going to erase all this work. Let's take a look and try B. So with B, we have an A value of 1, but we have a B value of positive 4. So that would be negative of positive 4 divided by 2 times 1, which equals -2. And that is the axis of symmetry for graph A, so it would have to be B. Now we'll go through the same exercise with graph B. With graph B, it's a downward facing parabola, so A cannot be right, B cannot be right. So let's look at C and D. So for C, if we try C, we have an A value of -1 and a B value of -6. So let's find the axis of symmetry. Negative times -6 over 2 times -1, which is 6, positive 6 over -2, which is -3. Well, we need an axis of symmetry, a positive 3. So this C does not work, but we will still check for D to see if that works. Let's go through that same process again. So looking at D, we have an A value of -1 and a B value of positive 6. Let's try the axis of symmetry. So it would be -6 divided by 2 times -1, which would equal -6 over -2, which would equal a positive 3. And this checks with the axis of symmetry of 3. So D is the correct answer. So that's all we had for you today. I do have the rest. This is the rest of the homework. Number 5, 6, 7, and 8. And then I have a little fun for you to do. Doodle flow writing is really fun. You should check that out. I have a word search, and then I have the answers for last night's homework, if you'd like to check those. So keep up the good work. You'll get your S back next week. But meanwhile, just keep on practicing, because as you do, you know the drill. You can't help but be great.